So we're going to talk about applying the Pythagorean theorem and the converse of the Pythagorean theorem to solve triangles. Pythagorean theorem looks like this: a squared plus b squared equals c squared. And the key is that the c squared has to represent the hypotenuse, and the a squared and b squared are the two legs of a right triangle. Remember, the hypotenuse is opposite the 90-degree angle. Okay? So we want to solve for x. First thing we need to do in using the Pythagorean theorem, and this reminds me, make sure when you're doing your homework, you're showing your work. While you have our answers, I'm going to think you're either getting them out of the back of the book or my book or somewhere online you found all the answers and you're very creative. And I'm not going to give you credit for that from now on. Okay? While you have our answers, then you can just hold on to it because I'm not going to give you any points for it. We first, after we write down the Pythagorean theorem, we have to identify which one of these is the hypotenuse. Which letter represents the hypotenuse?
13.
Which letter represents the hypotenuse? And it is 13. Good. So this is the hypotenuse, and the hypotenuse in the triangle is 13. So I plug that in there. So where do I put the 5 and the x?
They're interchangeable.
Okay, it doesn't matter where I put them, in other words, right? As long as I put them in for the legs. And so I'm going to say x first plus 5 squared equals 13 squared. So x squared plus 25 is equal to 169. If I subtract 25 from both sides, what do I get? 144. Now what do I do?
Square root.
Square root both sides. Don't divide. Square root both sides. And we get 12. Okay? So the numbers 5, 12, and 13 represent what is called the Pythagorean I just realized I spelled Pythagorean. I knew that looked wrong. No, this is right. I spelled it wrong earlier. I went Pythagorean. It's Pythagorean. Pythagorean triple. Okay? This is called a Pythagorean triple. So any three numbers that meet the rule of the Pythagorean theorem are called a Pythagorean triple. The most common Pythagorean triple that I want you to learn, and you should learn it really well because it's going to be used from here on out. And it's the kind of question that they love to put on the ACT. It's called a 3, 4, 5 triangle. 3, 4, 5 is a Pythagorean triple. Now they're going to give you some homework questions where they're going to say, is this a Pythagorean triple? And you're going to have to test it. Well, the way you test it is you put it into the Pythagorean theorem. So the two legs have to be the two shorter sides. The hypotenuse has to be the longest side. So 3 squared plus 4 squared equals 5 squared. And we're really asking the question, is that true? Okay? And 3 squared is 9. 4 squared is 16. 5 squared is 25. What's 9 plus 16? 25. So 25 is equal to 25. And so the answer is yes. 3, 4, 5 is a Pythagorean triple. Well, we already knew that. I already told you that to begin with, right? It's the most common Pythagorean triple there is, and it's the one that's used the most often. Okay? Let's go back and fix this. And you know, when I wrote that, I thought, man, something doesn't look right, but I just kept it going because I'm in a hurry. Okay? Pythagorean triple, the Pythagorean theorem. All right? Any questions on Pythagorean triple? Okay, let's try one more. Is this a Pythagorean triple?
Mr. Mitchell, do the numbers have to be what? It has to be
No. The first one was a 5, 12, 13, right?
That's not.
So check this one. Is it Pythagorean triple? What do you think, Jocelyn?
No,
No, why not?
because 49 plus 64 does not equal 81.
Okay, you're saying 7 squared plus 8 squared does not equal 9 squared because 49 plus 64 does not equal 81. What does 49 plus 64 equal? 113, and I agree that does not equal 81. So the answer is no. It's not a Pythagorean triple. Okay? All right. Any questions on this? Okay. The converse converse of the Pythagorean theorem says the opposite of what the Pythagorean theorem says. It says if the sum of two legs of a triangle, if the sum of two sides of a triangle, let me try it again. If the sum of the squares of two sides of a triangle is equal to the square of the third side, then the triangle must be a right triangle. So the Pythagorean theorem says, hey, if this is a right triangle, then the squares of these two sides has to equal, added together, has to equal the square of the third side. Now the converse is saying, if we just have this triangle here and we don't know if it's a right triangle, but we see that the sum of the squares of two sides of a triangle is equal to the square of the third side then it is a right triangle. So in other words, we can use this theorem to help us determine whether the triangle is a right triangle or not. Okay? And I'm going to put two more theorems on here. And I'm not going to write them at all identical to what's in the book. They actually come from page 360. And they're titled Theorem 7.6 and Theorem 7.7, and they really don't have names to them. But they go right along with this same concept. And what they're saying is, if a squared plus b squared is bigger, let me try again, is less than, I'll get it right, is less than c squared, then the triangle is obtuse. What's obtuse mean?
It has one of two singles.
Okay, good. So that means we're looking at something like this. Okay, that means we're looking at something like this, and so let's see, this would be B, C, and A. So that means triangle ABC is an obtuse triangle. Angle C is bigger than 90 degrees. If it's equal to 90 degrees, then these two are going to be equal. The sum and this side are going to be equal if this angle here is 90 degrees. If this angle here is bigger than 90 degrees, then that means this side is going to squared is going to be more than the other two. Okay? It's going to be more than the other two. And then the third one says that if a squared plus b squared is bigger than c squared, then the triangle is acute. And so I don't know if I'll let them- Let me just draw one like this. So in this situation, all three angles are less than 90 degrees. And the longest side, the square of the longest side is less than the sum of the squares of the other two sides. Okay? So that's how that looks. And so, to practice this, they're going to say, if these are my sides, they're going to say, is that a right triangle, an obtuse triangle, or an acute triangle? They want to know what kind of a triangle is that. Right, obtuse, or acute? So how would I test it? Say it again. Okay, so you mean 7 squared plus 8 squared, and then we don't know what goes in there, do we? Is it less than or greater than or an equal sign, right? We don't know what goes there. So just put a box there for now. So this was 49 plus 64, and this is 144. And we just said this is 113. 113 is less than 144. So the side that's all by itself squared is bigger than the other two. That makes it what kind of a triangle? Obtuse. So if this side squared is bigger than the other two, then that makes it an obtuse triangle. Okay? So that's an obtuse triangle. Now, if my third side was 9, like I had earlier, and so that meant instead of 144, we had 81 here. Now 81 is not bigger, but it's less than, so now it's an acute triangle. Okay, so now it's an acute triangle. All right? Any questions on those? Okay, I'm going to pause so that I can pull up the calendar and look at the assignment. So we'll stay with the assignment, lesson 7-2, 3 to 57 by 3s. Remember tomorrow, we'll be checking this, so get it done.